Hi, I'm Jamie Curtis, Team 36. Today, I would like to introduce you to our project, Grid Reliability Analysis Software Platform. There is a plethora of data available in the electric utility sector at substations and other field devices that is rarely stored and analyzed in a central location. Grid Reliability Analysis Software Platform, also known as GRASP, is a web-based application that is designed to centralize electrical fault events generated by field devices into a central location. These centralized fault events can then be analyzed in a common location by multiple departments within an electrical utility to make informed operational, protection, automation, and maintenance decisions in an efficient manner. As devices in the field experience faults, they store them. The goal of this platform is to ingest those faults and to display them for future use. We will now go and upload a few sample fault files. As you can see, we have to choose a substation that the fault was generated from. We have some simulated faults that we'll go through. We'll also pick the relay in case this substation has multiple relays. You can see here that we have a pre-selected number of faults that we would like to create. They were simulated in MATLAB. We're going to upload them. Now we're going to add some additional faults from a different substation on a different line. As you can see, we've given you options for different quick filters. So we'd like to go back to last year and have a look at these faults. As you can see, they're now displayed graphically at the appropriate location on the line. You can also opt to select a feeder that you would like to filter by. In this case, we'll filter by the Gladstone-Clifton. You're able to zoom in thanks to Google Maps and have an exact look at the location of the fault. Now that we're in Explorer, we can click on a fault, have a look at all the pertinent details such as the size and location. You can also copy it to your clipboard if you'd like to paste it somewhere. Then you can click on Workbench, which will take us to the workbench. Once you are in the workbench, you can see more pertinent details about the fault event. Here you can see some of the information that was scraped from the file, including the fault currents of each phase, the distance to fault as was prescribed by the relay that created the file, and then the distance to fault that our platform calculated based on the raw data. You can also see the current and the voltage waveforms, and you can see where the fault occurred on phase B. So now that we're in the fault, we can go ahead and update some notes. In this case, we know that this fault was caused by wildlife, specifically a squirrel. So now that we have this information captured, we can move on to the analytics portion. In the analytics section, we have demonstrated the software platform's capabilities as far as graphing, clustering information, and showing relations between data. In this graph, you can see we are graphing the distance to fault to the fault current. Now that you've seen the clustering ability of the software platform, we're going to move on to the History tab. In the History tab, you can see the information of all the faults that have been uploaded. In this case, you can see since we clicked on the fault in the Explorer view and added the wildlife information to the cause, this row is selected. And click Edit, and that will take us back to the workbench. Now that we've selected a fault that we're wanting to look into, we can actually go to the Explorer and show the information there as well. You will notice now we're on a different fault and it has focus. If we remove focus, it will no longer be selected in all of the other tabs. I hope you've enjoyed this brief presentation showcasing Grid Reliability Analysis Software Platform's strengths. Thank you.